Okay, so we're still factoring special products, part 2. And this is like the one you just asked me about, number 20 in the homework. So after we go through this, hopefully you will have a better understanding of how you should have done it if you weren't successful with it. So we have a square piece of cloth that must be cut to make a cover for a table. The area needed is the polynomial 16x squared minus 24x plus 9 inches squared. Okay, well that's area. How do you find the area of a square? Length times width. What do we know about a square's length and width? They are the same. So it kind of sounds to me like if we're already given the area, we are given the product, we need the what?
Square.
We need to find we need the length and the width, and then we just decided they're the same. So we really just need to do what with this area if we want to know a side length?
Divide.
Not divide.
Square.
Find the factor of it. Get its factored name. Find what is the square root of it, basically. Which we're not really learning right now how to do, is how to find the square root. What we're learning is how to factor it. And then we'll be able to, in our next chapter, be able to find the square root. Okay, so the dimensions of the cloth, it says, have the form of ax minus b, where a and b are whole numbers. Well, that tells you what about that trinomial? What does it have to be then if the dimensions of the cloth have the form of ax minus b? What is that trinomial? Well, a square has the same dimensions, length is the same as the width, and they're saying that it is ax minus b. So basically we're saying its dimensions would be ax minus b times ax minus b, which is a binomial times itself, which means then that we should be able to almost assume that this trinomial is a what? Perfect square trinomial, because isn't the factored name for a perfect square trinomial a binomial times itself?
Yeah.
Yes. Okay, so we are going to be looking for if we have to find the perimeter, we got to know the dimensions, right? How do we find perimeter?
Length plus plus width.
Okay, length plus another width plus another width plus a width plus another width. In other words, we have to add up all 4 sides, right? Well, basically, we're going to have 4 sides that are the same, so we should just be able to multiply, right? We should be able to say, here's the dimensions of one side, multiply it by 4, and that will give us the perimeter. Okay, well, let's find, and then we have to, so we have 2 parts to this. We have to find the expression for the perimeter, and then we have to find the perimeter when x equals 11 inches. Now, if in your homework, what you tried to do was substitute 11 in for the x in the trinomial, what were you really getting? Were you getting perimeter when you did that? What were you getting? The area. That's the area. So that is not what we want to do to find the perimeter. So we're going to have to first of all figure out how long, what the dimensions are of this particular square. So let's draw a square first of all. Let's just draw ourselves a better square than I am right now. Make it somewhat look like a square anyway. And we know that the area of this, so I'm going to have to put mine over here because I did not make my square big enough. We know that the area is 16x squared minus 24x plus 9. And do we know what they're measured in? Inches squared. Okay, so when we get the dimensions, they would be measured as what? Inches. Okay. So the area of a square, we should be able to just say is area should equal side squared. S standing for the side length. So let's put that over here. S equals side length. Well, let's just double check. It should be a perfect square trinomial, but let's make sure it is. Is 16x squared a perfect square?
Yes.
Okay, how about 9? Is it a perfect square?
Yes.
Okay, what's our other test? Has to have what at the end?
Addition.
C has to be positive, it has to have addition at the end, and the middle term has to be what?
Even.
Well, didn't you run this test? The middle term has to be, maybe if you don't yesterday's notes, double the
A and C.
square root of
Square root of A
the
and
first
C.
term and the square root of the last term. So what is the square root of 16x squared?
4.
4x. And what's the square root of 9?
3.
What's 4x times 3?
12.
12 and x. And then we have to double it. 24x, and there is a 24x in the middle with subtraction. So that means what again? There's going to be what in our binomial? Subtraction. Okay. So basically what we are doing then is we are going to factor our perfect square trinomial. We just ran it through the test and said, you know what, it is a perfect square trinomial. We don't need A, B, and C because we've already determined it is a perfect square trinomial, so all we have to do is what we just verbally did, take the square root of the first term, the square root of the last term, and you already said it has to have subtraction in the binomial because it's a negative b term, so its factor name would be what? 4x minus 3 squared. But not inches. Right now, if we write it like that, that's what? What is that? That's inches squared. That's just the new name for the area. So if we want to talk about the dimensions, we are going to say it is a 4x minus 3 inch by 4x minus 3 inch squared. Each of those binomials are inches, but when we multiply them together, show them squared, they're still inches squared. Okay, well that's not what they were asking for, is the dimensions. They were asking for an expression that would show the perimeter. So for the perimeter, number one's answer, we have 4 sides that are equal, so we would say 4 times 4x minus 3. Are these inches still, or are they inches squared? They're still inches. We're adding inches up, and inches added to inches is still inches. And then let's simplify this. We have, what does this become? 16x minus 12, and those are inches, right? So there's our first answer, an expression for the perimeter. And then the second answer says, well, what is the perimeter when x equals, is it 11? Okay. So basically we are going to substitute in 16 times 11, and then we will subtract 12. Well, 16, don't take your calculators out, seriously. 16 times 10 is?
160.
160. We need another 16 though, so 160 plus 16 is?
176.
176. And 176 take away 12, that's not too hard to do either. What is it? 164, and those are inches. So our perimeter is 164 inches when x equals 11. Okay, is this not like the problem you had in your homework number 20? Okay, better understanding of it now? Yeah. Questions? Any parts you want to talk about? Because we did not do so well with area back in the last chapter. Would somebody like to take care of that crazy sound? Okay, or maybe it was a sound.
It was a sneeze.
Well, some people have a sneeze for their phone ring. Did you know that? Oh. Okay, let's go to the backside. This is where you better really put your thinking caps on because this is gonna lead into what we're also gonna be doing on Monday, okay? So it says sometimes you can use some other method of factoring first, and one of the factors that you end up with is a special product. So then we have to factor that also. So we don't look at something like 6x squared minus 6y squared and give up too easily, in other words. Because right now, would we say that that is a special product? 6x squared minus 6y squared. Is it a special product? Called the difference of squares? How do we know if it is or isn't? What's the first test for a special product?
If
If the beginning and ending term are perfect squares. Well, this one only has two terms, so both of them have to be perfect squares. Is 6y, or 6x squared, excuse me, the first one, is it a perfect square?
no.
X squared, the x squared part is a perfect square, but is it 6?
No.
No, it's not. So right now we would say no to this one. We would say both terms are not perfect squares. Well, guess what? We're going to make it so that we do have some perfect squares. What can we GCF out of that?
3x.
How about a 6?
Oh.
Okay, so 6 can be divided out of both terms. So we are going to end up with 6 times x squared minus y squared. So now, do we have 6, of course, is just a GCF that we can't do anything more with. But how about the x squared minus y squared? Is that a special product?
Yeah.
Yes, because it begins and ends with perfect squares, and it has subtraction, doesn't it? So we are going to factor that now. So we're going to just arrow this 6 down so we don't forget about it, because it's still going to be part of our end answer. And now we're going to say, okay, well, I need the square root of x squared, and I need the square root of y squared. And what is the square root of x squared? X. And the square root of y squared is y. So that says that both of our binomials are going to start with x. They're both going to end with y. Do they both have the same sign? Or do they have opposite operations? Opposite operations. Binomials for difference of squares, one has addition, the other has subtraction. So now we can say, this binomial has a 3-part factored name. Okay? Questions? Okay, let's try another one. 12x to the 4th minus 12y to the 4th. Right now, as it stands, is it a special product? No, because
12 is R.
yeah, 12 isn't a perfect square, is it? Okay, well then we're going to do what? What can we do? We can GCF what? What can come out? A 12. So we're going to have x to the 4th minus y to the 4th. Is that x to the 4th minus y to the 4th a special product?
Yeah.
Yes. Okay, that means we're going to keep factoring. So I'm going to arrow down that 12. And I'm going to say the square root of x to the 4th is
X squared.
x squared. And the square root of y to the 4th is
Y squared.
y squared. Okay, what are the binomial factors then?
X
X squared
plus Y squared.
plus y squared.
And X squared minus Y squared.
Okay. And I bet you think we're done.
No.
Oh, you don't?
It's 12. 12.
Oh, I already told you. Well then, so basically this is what we have to start being able to do. We have to be able to say, those new factors that I now have, can they be factored?
Yes.
Oh, yeah.
So can x squared plus y squared be factored?
Yes.
Why?
Because they're both squared.
Because they both start, it begins and ends with a perfect square?
They're both special products.
They're both special, oh, no, I don't think so. I'm gonna disagree. Why isn't x squared plus y squared a special product?
They don't have to.
They're not
Oh,
two
they don't
things.
have subtraction.
Oh, it doesn't have subtraction, it has
Addition.
addition, so we can't do anything with that. Okay, that one's just gonna arrow down also. How about x squared minus y squared?
Yeah.
That one we can factor, can't we? In fact, we just factored x squared minus y squared up above, didn't we? What were its factors?
Y.
X plus y and
X
x plus y, x minus y. So we're renaming this as x plus y, x minus y. It can still be factored. So now, can x plus y be factored? No. How about x minus y? No. Okay? We are finally ready to bring everything together. We have a 12. We have an x squared plus y squared. We have an x plus y. And we have an x minus y. It has a 4-factored name. That little measly binomial we started with. But being able to factor like this is going to help us in the solving process when we have something bigger than a linear equation to solve. That's the only type we know how to solve right now. Okay, questions? Okay, I don't know necessarily how much you'll see this in the homework today, but you may. But we will definitely be seeing it on Monday, okay? So this is nothing else, it's prelim to that. So no questions? Okay, then let's spend the rest of the class time that you have doing homework.